Over 70% of Earth's surface is covered in water. With such a vast covering on our Earth, one would think that water is overflowing our Earth. We met with a water expert from Columbia University, Ana Quintas, to explore our Earth's water supply and the expansive groundwater reservoirs just beneath our Earth's surface.
Currently, of the Earth's available water sources, 97.2% is in the form of salt water located in our oceans. Only 2.8% of water is in fresh water. Of the fresh water on Earth, a good portion is frozen in the form of ice and glaciers. Very small fractions of water are readily available in water bodies, such as streams, lakes, and rivers. With due reason, this issue is becoming more and more pressing as we continue to use up our remaining resources.
We just heard about water above ground, but what lies beneath the surface? Listen, as Ana, the expert in hydrogeology, explains what can be used from our expansive supply of groundwater in the phenomenon of aquifers.
Aquifers, a permeable layer of rock and sediment holding groundwater, are important to many organisms, including humans. To visualize an aquifer, the best analogy is to think of a beach. When a hole is dug into the sand on a beach, wet or saturated sand is eventually reached. The hole is representative of a well to reach the aquifer, which is represented by the wet sand. When the water reaches a certain level after rising in the sand hole, this is also representative of the water table in an aquifer. There are two types of aquifers, confined and unconfined aquifers. Unconfined aquifers have a permeable layer of clay before the water, whereas confined aquifers have an impermeable layer of rock and clay. Through a process called groundwater recharge, which is where water percolates through the soil to work its way into an aquifer. Confined aquifers can only be recharged if there is an opening at land surface to the recharge area. From an aquifer, humans can dig wells to obtain fresh drinking water. A special type of well is the artesian well, which can be created from digging into a confined aquifer. Too much well drilling can cause saltwater intrusion, which can ruin an entire supply of drinking water in an aquifer.
So, what's an example of an aquifer situation?
Aquifers can range to giant sizes. The largest aquifer in the United States is called the Ogallala Aquifer. It is located in the Great Plains. The Ogallala Aquifer has been a great source for the local people for household, agricultural, and industrial uses. The rate of recharge of the Ogallala Aquifer is not keeping pace with the withdrawal rate. From a high withdrawal rate, a cone of depression is occurring at this aquifer, and any other aquifers that will suffer from this issue. At the current rate, the aquifer and the Great Plains will run out of water within a century due to the unsustainable practices that are currently occurring. So, groundwater currently is a good source for water that should be utilized with the proper precautions. It has the ability to sustain much of the human population. With the proper usage, the small percentage of groundwater and streams that are available on the Earth's surface must sustain the entire population, since most of the water in the world is currently in the saltwater in the oceans, as mentioned before, with a 97% that is unusable to humans.
Humans have had a profound effect on the world. Specifically, they have affected the availability of water in order to conserve the world's most profound resource. Here, we have Tyler Chartash of Duke University, who is a PhD in water. Tyler, what types of structures have humans created to alter the availability of water?
Well, humans have done a lot to alter the availability of water. We have created levees, dikes, dams, and aqueducts. Levees are enlarged banks built up on the side of rivers to prevent flooding of the river. The Mississippi River has the largest system of levees in the world. It is enclosed by almost 1,500 miles of levees and protects 15 million acres from flooding. Floods used to be imperative to the farming cycle. Floodwaters would add fertility to the floodplains by depositing sediment onto the soil. Now, the levees keep all the sediment and extra water in the river. This means that the sediment can be deposited into the ocean, and flooding can be worse than before if the water is able to pass the levees due to increased flow of water in the river. An example of levee failure is Hurricane Katrina in New Orleans. There was so much water in the rivers due to the hurricane's rain, and the pressure of the water caused the levee to collapse. This resulted in horrible flooding of the city, and many homes were destroyed.
So, what about dikes?
Dikes are very similar to levees by preventing flooding, but due to ocean water. They are very common in areas where much of the land is below sea level, such as off the coast of Scotland. Recently, dikes have had a great technology improvements. Many now include electric and diesel pumps, so if water goes past the dike, the water can be moved back into the ocean.
So, are dams and dikes similar?
Dams also create a barrier along a stream similar to levees and dikes, but the goal of a dam is to manipulate the water in order for the water to collect in a single area called a reservoir. The water in the reservoir can be used for human consumption, generation of electricity, flood control, and recreation. There are 83,000 dams in the United States, the largest of which is the Fort Peck Dam along the Missouri River. It is 130 miles long and 62 meters deep. Interestingly though, only 3% of dams in the United States are used for hydroelectricity, while 38% of dams were created for recreational purposes. But dams interrupt the natural flow of water and can disrupt the migration of fish such as salmon. That has led to the invention of a fish ladder on the dam, a set of stairs with water flowing down so the fish can still migrate upstream by jumping up the stairs.
So, are aqueducts the same as dams?
Not quite. Aqueducts do not block water. They use canals or ditches to carry water from one location to another. This system started 7th century BCE in Greece. Now, modern aqueducts are made of pressurized steel pipes and can carry water over 120 miles, exemplified by the Catskill Aqueduct, which brings water from the Catskill Mountains into New York City. Nowadays, there is a concept called desalination, which removes salt from water to make it drinkable. The most common techniques for desalination are called distillation and reverse osmosis. Distillation boils water. That allows the water to evaporate while the salt stays behind, and then the steam is collected and condensed into pure water. The other technique is reverse osmosis. Water is filtered through a semi-permeable membrane at high pressure. The water is able to pass through the membrane, but the salt cannot.
The fresh water on Earth that exists above the ground is called surface water. This includes streams, rivers, ponds, lakes, and wetlands. We met with water expert Tori Lai of Harvard University to further discuss the characteristics of this type of water resource.
Surface waters have many different functions. In early civilizations, humans tended to settle along rivers because the currents serve as a form of transportation. The land adjacent to rivers is also often extremely fertile. This land is known as the floodplain. When rivers naturally overflow during spring snowmelt or heavy rainfall, the nutrients from the excess water absorb into the soil. One of these well-known early civilizations includes the ancient Egyptians, who took advantage of the fertile soil along the Nile River for commerce.
Many large cities today are located along rivers for these same reasons. Some of the North American cities include Pittsburgh, New Orleans, and St. Louis. The waters on the Earth's surface are formed when depressions in the landscape are filled by precipitation, unabsorbed runoff, and flowing groundwater. Lakes are commonly created due to tectonic activity and/or glaciation. Tori further explained how these processes occur.
During tectonic activity, areas of land rise, which may isolate a region of an ocean. When this happens, the lakes form, and the lakes caused by this often have higher salinities than others. The Caspian Sea is an example of a salty lake formed by tectonic uplift. As many of us know, glaciation refers to the movement of glaciers. These glaciers scrape depressions in the land, which eventually fill with water. After thousands of years, lakes form. The Great Lakes in North America are thought to have formed because of this glaciation process.
There are also different classifications for lakes. These surface waters are classified by their level of primary productivity.
The nutrient levels in the water determine the productivity of a lake. These nutrients include phosphorus and nitrogen. A lake is oligotrophic if it has low levels of nutrients, thus low productivity. Lakes with moderate levels of productivity are known as mesotrophic. Lakes with high levels of productivity are known as eutrophic.
Another essential form of water on Earth is the water that exists in the atmosphere. The atmosphere that surrounds us holds a very small percentage of Earth's total water supply. In her water studies, Tori also focused on the importance of atmospheric water. Many do not realize that humans may cause these detrimental effects of droughts. However, many of these effects are indeed worsened by our own activity.
Yes, we do have significant responsibility for our own suffering during droughts. Take a look at the American dust storms in the 1930s. During those decades, Americans dramatically converted native grasslands into wheat fields. Naturally, wheat fields are more likely to experience soil erosion by wind than the native grasslands. So when we converted the land, we created many more hectares of erodible land. When the drought occurred, crops failed, leaving loose soil that picked up with the wind, and dust storms formed, leading up to what we know as Black Sunday and a decade of dust storms after that.
In addition to dusty windstorms, drought-prone areas also experience severe flooding when the rare rain does occur. California is one of these areas with some serious flooding problems when the state experiences the sporadic rainstorms.
Similar to how we influence the impact of droughts, our infrastructure is also responsible for worsening the risk of flooding. In a natural ecosystem, porous soil and wetlands soak up heavy rainfall. However, we've created huge areas of impermeable surfaces by constructing buildings and laying out pavement. These surfaces do not absorb water at all, so the water from the storms runs off into the surface water areas, lakes and rivers, which eventually overflow.
So we have heard a lot about water from a lot of experts, but how does all of this relate to humans? Here is expert Ryan O'Keefe of Princeton University, who has studied the interactions between humans and water for several years. Ryan, what are some basic uses of water?
As many of you are probably already aware, water is vital to human survival. We can only survive a few days without it, but beyond drinking, water plays other very important roles in human survival. In everyday life, we see water used in multitudes of different things. Though, the three main areas we see water being used in everyday life is for agriculture, industry, and households. Right now, about 70% of the world's fresh water is used for agriculture. Agriculture is very important because of its ability to produce food and income for people.
So then how is the water used in the agricultural process?
Through irrigation, and there are multiple ways of going about irrigation, many of which vary in cost and effectiveness from each other, though all result in watering their crops and helping produce income for both farmers and consumers. Furthermore, scientists actually have created agricultural techniques to help reduce water amounts and save water for other uses. Even though these techniques are highly effective, they are much more expensive too.
Interesting. Now, how does water affect industry?
Water is necessary for many aspects of industry, such as generating electricity, cooling machinery, and refining metals and paper. In industry, there are two ways in which water can be used. It can be either consumed or not consumed. In many things, such as generating electricity through hydroelectric dams, water is not consumed. Rather, it is recycled and used again. Though, on the other hand, water can also be consumed in other things, such as cooling the nuclear reactor of a nuclear power plant.
And then finally, Ryan, can you please speak to us about the everyday use of water within a household?
The average person within the U.S. holds about 157 gallons of water per day. From taking a shower to washing your clothes, water is used in a lot of activities done around the house. Though when you evaluate a less developed nation, you will see a drastic difference between the water amount compared to other countries such as the U.S. and in many times in developing nations that struggle just to find clean water to drink.
Thank you for speaking with us about water in the world today.
Ownership of water resources seems to be a recurring topic in the news lately. Can you briefly describe the topic and tell us what are your feelings on it?
Anytime, any place on you, Deep.
Well, how about right now?
Where?
Brandon?
I'm just rustling your jibbies, Deep. Ownership is tossed country to country, but looking at this issue on the macro scale has negligible importance because environmental harm pertains to each of us individually. Realistically, everybody is responsible for the current environmental desecration, yet governments are responsible for their people. Ownership needs to be taken by the UN, but specifically the countries that pump out CO2 like Old Faithful, such as China, the US, and Russia.
Do you believe this to be a top priority of the US government and the UN?
The UN has made regulations across the world, but they aren't strict about seeing their regulations through. China is still the highest in CO2 emissions despite years of the UN's so-called progress. China is still the highest in CO2 emissions despite years of the UN's so-called progress, just said that sentence twice, on reducing their emissions. The US government needs to act like the superpower they are and make some serious changes before it's too late. Despite the lack of leadership, the U.S. is constantly regulating our own CO2 emissions and water use in the United States of America. In 1995, a regulation was made that reduced the amount of water used for a toilet flush from 27 gallons to only 6, and I think that's amazing.
So, what else can we do around the house to reduce our independent footprints, Brendan?
Well, on you deep. That's a key question. Since 1995, regulations have been made on laundry machines, dishwashers, and showers, and are constantly being improved. You should buy new, efficient appliances and cut down on waste by recycling as much as possible. Also, people at home, I would like to point out that saving the environment and saving money go hand in hand. When you buy a more efficient dishwasher, it fashions a first-class price tag, but the monetary saving you'll be doing every day will make up for it within months.
Could you talk of some of the current issues involving resource depletion? Because I know that has played a large part in the battle for sustainability.
Yes, Deep. Can I call you Deep? Is that okay?
Yeah.
Great. Great question. Resource depletion is the very reason that we strive for a sustainable world. India and Bangladesh are currently arguing whether or not India has the power to divert some of the water from the Himalayan mountains back to their population. Bangladesh government officials argue that the water has always run down into their territory, and therefore it is just as much property as theirs.
Are there any simpler solutions?
It's in the people of India's best interest to lower their birth rate, because it is the most overpopulated country in the world at a staggering 1.25 billion, and a birth rate decrease could steer that towards a safer number while also solving the issue of thirst between both countries.
You would think they would consider that as an option, wouldn't you?
I wouldn't personally. People don't understand the importance of abolishing freedom to overpopulate. It's a big issue.
One of your ingenious research papers in college listed potential of gray water recycling. What's that all about?
Gray water is left from laundry machines, dishwashers, and bathroom sinks. This water could easily be reused for toilets, from toilets, instead of using pure drinking water and contaminating it. So basically, you can take used water from bathroom sinks, laundry machines, and dishwashers and pump them into the toilets instead of using pure clean water that you could drink and wasting it.
That's interesting. Can you leave the audience with a summary of acts to avoid and remember when it comes to being sustainable?
Of course. Do not buy a swimming pool. That's number one. Look into using gray water for toilets and mowing the lawn. Make investments in the name of Mother Nature and don't take so many dang showers. Water and oil, save them.
Thanks, dog. Keep it tight.
Humans tended to settle along rivers because the currents serve as Surface waters have many different functions. In early civilizations, humans tended to settle along rivers because the currents serve as a form of transportation. The land adjacent to rivers is also often
Very important roles in human survival. In everyday life, we see water being used in multitudes of different things. Though three main areas.
Okay, what are we doing?
That's the other that can be used. It can be either consumed or not consumed. And many other things such as generating electricity through a hydroelectric dam. Just start that over.